Today we're starting our topic on probability. So, what we're doing today is we're just doing a bit of a recap of what you've done in all your other years of high school. So, we're reviewing the terminology related to probability and also calculating probabilities of simple events and experiments. So, by the end of this lesson, you should be able to define and use these terms with confidence to calculate some simple theoretical probabilities, and also to calculate relative frequency or experimental probabilities. So just to start off with, here's some terminology that we use a fair bit of. So the first word that we use a fair bit of is a trial. So if we're talking about a trial, we're talking about one lot of doing an experiment. Okay, so it's a single occurrence of a chance experiment. So if I were tossing coins and noting down whether they were heads or tails, then if I toss it once, that's called a trial. If I toss it many times, then it's called an experiment. The sample space is the list of all possible outcomes of an experiment. So what are the possible things that you could get? So if I was tossing a coin, then I could get either heads or a tail. There's not really anything else we can get. If I was rolling a die, then I can get the numbers 1 to 6, okay, if it's a normal standard die. So that would be your sample space. If we're talking about an outcome, you're looking at a possible result of an experiment. So it's one of those results. Okay, so if I'm talking about tossing a coin, it's a head. Okay, that would be an outcome. Or it's a tail. Okay, that would be another outcome. An event is a collection of outcomes resulting from an experiment. So if we were to perform some sort of trial many times, then an event, we're talking about what is the final result. Okay, so what's the final conclusion from completing that experiment? So if you were looking at tossing 3 coins, so it could be an event could be getting 2 heads, okay, or if I was rolling two dice together, then it could be obtaining a sum of 7. Okay, so we're looking at multiple things happening together and looking at what the results come out to be. If we talk about outcomes being equally likely, what that means is that each of the outcomes has the same chance of occurring. So if I am rolling a die, one side isn't going to fall more than another side, okay? Or if I was picking a letter from the alphabet at random, okay? Those things are equally likely. Whereas if I was looking at picking the first letter of a person's name, that's probably not equally likely because each of the letters don't have the same chance of appearing as the first letter of a person's name. Okay, or if you were trying to pick a letter from by just opening a book, that's not going to be equally likely because some letters will appear a lot more than others. Okay, so you just need to be a bit careful with that equally likely. So if outcomes are equally likely, we can easily work out probabilities. So the probability of an event happening, which we write as P bracket event. So inside the brackets, we usually write a little description of what we're looking for. So it might be P bracket head, one head. Okay, and that would be the probability of tossing a head. Okay, so that's what we would fill that inside gap with. So the probability of something happening is the number of favorable outcomes over the total number of outcomes. So how many of the sides of the die are what we need over the total number of sides of the dice. Okay, something like that. If we're looking at experimental probability, we're looking at probability calculated based on an experiment. So it's not something that we intuitively know. So if we're looking at a die, we know that there's 6 sides. Each of the sides is equally likely, so then we can calculate probability. But it could be something like, what is the probability that someone off the street is going to tell you that they like shopping at Woolworths or something like that? That's not something that you can calculate, but what you can do is you can do many trials of that experiment, and then you can use that to estimate further probabilities. Okay, so that's what it means by experimental probability. Or it could be a box with a whole bunch of marbles and you don't know what sort of colors you've got, so you might do lots and lots of experiments to see what sort of numbers you're getting, and then you can use that to estimate how many marbles are in the box, how many of each color of marbles is in the box or something like that. So if we're looking at experimental probability, we're looking at the results of the experiment. Okay, so the results of the experiment don't always necessarily reflect the actual trial. So if I were to actually physically toss a coin 100 times, the chance of it being perfectly 50-50 is actually quite low. Like I might get a 49 and a 51. Another person who might toss a coin 100 times might get a 52 and a 48. Someone else might even get a 40 and a 60, and that's possible too. It's just the luck of the toss. So when you're looking at those, then those would be considered your experimental probability. So even though we know it should be 50-50, when we actually go to actually perform the experiment, it may not be. One last thing, the complementary event. So if we talk about the complement, so if I have a certain event A, the complement is the opposite. So the complement of event A is the event where A does not occur. So it's sort of just complete opposite. So if I want to find the complement of tossing a head on a coin, then we're looking at not tossing the head, we're tossing a tail. Okay, if we're looking at the probability of it being sunny tomorrow, the complement would be it's not sunny tomorrow. So it's not necessarily raining because it could be hailing, could be cloudy, it could be thunderstorming, it could be something else. So often we'll use the word not to represent it. Now, if we're looking at writing this notation, often to write the complementary event, we might write it as A with a line on top, okay? So that's a notation that we use for complement, sometimes with the dash, okay? Or sometimes we might have a little c, okay? Little c to mean complement. Now, if we have a look at the probability of something happening and the probability that it doesn't happen, if we add up those probabilities, we should end up with 1, okay? Because we sort of looked at all the different outcomes that could have happened, okay? So what we can do to calculate a the probability of a complementary event is the probability of the complementary event is 1 minus the probability of it happening. Okay, so the probability that it doesn't happen is 1 minus the probability that it does happen, because the two events should add up to 1 altogether. So let's have a look at a couple of examples. So a letter is chosen at random from the word probability. Find the probability that the letter is. So the first thing we need to do is we need to tally up what sort of letters we've got. We've got a P, got an R, an O, a B, an A, we've got another B, an I, L, another I, a T, and a Y. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. I hope I'm right. Yes. So we've got 11 letters altogether. What is the probability that we're going to pick an I? So let's use our probability notation. So the probability of getting an I. Now you can see we've got 2 I's out of 11 in total. So it's 2 over 11. That's it. For the second one, we want the probability that it's not I. Now remember, the word not means that we're going to be looking for the complement. So one way we could work this out is just to count up how many letters aren't I's, and then we can put that on top of 11. Or, because we know how many I's we have, we can work out the probability it's not an I by taking 1 minus that probability. And so that's 9 out of 11. So hopefully you got that too. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of 11. Sometimes it's faster to use a complementary event. Sometimes it's easier just to count them up. It's up to you what you want to do. The next one, we want the probability that it's a vowel. So vowels are your A, E, I, O, U. So we've got an O, an A, and two I's. So that's 4. So the probability vowel is 4 out of 11. And D, a letter that occurs on its own, so it doesn't have a double up. So we're going to leave out the B's, going to leave out the I's. That's 4 letters that we're taking out. So then the probability letter on its own will be taking out 4, so that's 7 out of 11. Hopefully that wasn't too hard. Hopefully it was a bit of review. With the next section, we're looking at an experiment. So an experiment was performed where 5 coins were tossed at the same time and the number of heads were noted. The results are in the table below. So after we did this, we had 5 times where we had no heads, so they were all tails. We had 14 times where we got 1 head, 24 times when there were 2 heads, and so on. So find as a fraction the probability of obtaining these possible things. So the first thing that we need to do is work out how many times did we actually throw these coins in the air. So what we need to do is we need to add up all of our results. So we need to work out the total. So 5, 14, 24, 21, 16, and 10. So we performed this 90 times. So find the probability of getting no heads. So the probability no heads. So no heads was 5 times out of 90. Now make sure you do simplify your fractions. That's going to be 1 out of 18. For the next one, we want 3 or 4 heads. Or 4. So we want either 3 heads or 4 heads, so we need to add those together. So 21 plus 16 is 37, so it's 37 out of 90. Now we can't simplify that any further, so we can leave it like that. The next one, we want the probability of less than 3 heads. Okay, so you can use some mathematical notation if you want. Less than, you can use the less than symbol. So less than 3 heads means that we want 2 heads, 1 head, or no heads. So we're looking at these 3 favorable outcomes. So we've got 24 plus 14, which is 38, plus another 5 is 43, I hope. So it's 43 over 90. Let's just double check that. Yes. So less than 3 heads, you want to count up how many of each of those. The last one, if I want at least 1 head, now there's a couple of ways of approaching this one. Often when I'm looking at the word at least, I actually like to use the complementary events to solve these questions, because the probability of at least 1 head, so the opposite of getting at least 1 is getting nothing. Okay, so if I want at least 1, so a minimum of 1, so it's 1, 2, 3, 4, or 5. So the opposite of that would be getting 0. So what we could do is we could write this as a complement. So the probability of at least 1 head is 1 minus the probability of no heads. Sometimes that's a much easier calculation to do. Or in the case of this, what you could do is you could go add all these together and put it over 90. If we work it out this way, we've already worked out the no heads probability, which is over here. So 1 minus 1 over 18, and that'll give you 17 over 18. Hopefully, if you add together all of these results and divide that by 90, you should get the same answer there. Alright, if I could get you to have a go at these questions, make sure we're going okay with probability and you understand the terminology. If you've got any questions, make sure you ask for help.